All right, you guys, we're going to do 1-3 notes today, solving and creating equations again. And today we're focusing on variables on both sides. Okay, so we're going to jump right in. Left side, then right side. Okay, so left side here would be combining like terms. So 3x plus 4x gives me 7x minus 10 drops. Let's distribute -2. So we have -2x. Negative times a negative is positive 8 plus 9. Then we have on the right side, adding like terms would give you -2x plus 17. Left side stays because nothing changes. Now, the part that's different is we have to move variables this time. So I always like to move from the right to the left on my variables just to keep them on the left side. It doesn't matter which way you choose to do it. This is just my preference. So 9x minus 10 equals 17. And then I'm going to add 10. And we have 9x equals 27. And last step is to divide. So x equals 3. Now, remember when you're checking these that you have to actually plug it in on each side and do them separately. So if this is 3, we would have 3 times 3 minus 10 plus 4 times 3. This side altogether, when you type it in, gives you 11. Then you have to do the same thing on this side. So -2 times 3 minus 4 plus 9. Typing it in also gives you 11, and that's what you want. These two answers need to be equal to each other because the sides are equal to each other. Okay? Then let's jump ahead to the next one. Distributing here, 1/3 d plus 4/3 minus 9. And then distribute your 1/2 gives you 3 minus 1/2 d minus 4. Combine like terms, 4/3 minus 9 actually gives you -7 2/3. And then over here, 3 minus 4 is -1. And then -1/2 d drops. Again, I'm going to add my variables from the right to the left so that they stay on the left side, just the way I like it. 5/6d minus 7 2/3 equals -1. I'm going to add 7 2/3 to both sides. And I get 5/6d equals 6 2/3. And then we have to, okay, then we divide. So divide both sides by 5/6. And d equals 8. Okay. Pause your video and do your try it's on your own, and then let's see if we can check the answer when you come back to it. Okay. So if you pause and come back, we should be at this letter A. So 100 needs to be distributed. So we get 100z minus 1, 2 here for that would be 20. -10 distributed would give you -50z. And here would be -8. So if I add 50z to both sides, I get 150z minus 20 equals -8. So add 20 to both sides. 150z equals 12. And if I divide by 150 on both sides, let me check my answer here to make sure I'm right. You should have z equals 0.08. Sorry about that. Okay, then following through, next one, we should have 5/8 distributed here. That's going to give us 10d plus 15 equals, and then I'm going to distribute here and get 60 minus 6 plus 1. Left side stays the same, nothing else to do. Here we're going to have -6 plus 1 is -5. Again, I'm choosing to move my variables to the left side, so I subtract and get 4d plus 15 equals -5. Subtract 15 and we get 4d equals -20. divide both sides by 4, and D equals -5. Okay, hopefully those triads went well for you. Let's go on to example 2. These are on here because they're just a little bit different. Hopefully this will jog your memory when you get here, but nothing on the left, so 4x plus 6 drops down. 2 distributes, and we get 4x plus 6. Now, if you notice right now, these two sides are exactly the same, which means something special to us, okay? What's going to happen here is if I subtract 4x from both sides, they both cancel out, and I am left with 6 equals 6. When there are no variables, okay, then you have two options. One is infinite solutions, and 2 is no solution. So you're looking to say if they're true or not. If these are yes, it's true, then these have infinite solutions. Okay, that means you can plug any number you want in here for x on both sides, and it's always going to equal the same. However, on this side, we drop 6x minus 5. We distribute, we get 6x plus 8. These are the same variable, but they're different amounts. So if we do subtract 6x from both sides, again, they both cancel, but we're left with -5 equals 8. This is not true. Okay, so if it's not true, then you're writing no solution. There is no number you could put on both sides to make that equal. Okay, so again, pause your video, try these on your own, see if you can remember which is which. Okay, if you come back to the video now, this side stays. This is -1 here, so we have to distribute and make them their opposites. If you look, even though they're reversed, -27 and t is positive, which means if I subtract my t's, they're both gone, and I'm left with -27 equals -27. This is true, so infinite solutions. Any number works. Okay, if I'm doing the next one, I'm going to distribute 16, and I get 164. I'm sorry, not 164, 64. Okay, 64 minus 48m equals, and then this side I'm going to distribute my 96 and get -48m plus 96. Okay, again, what's going to happen? 48m is going to be added, and both of them are going to cancel out at the same time. So you've got 64 equals 96, which is not true. Okay, so then we have no solution. All right, doing great. Here we go. Word problems where we're creating. So Cameron pays 95 cents per song with his current music service. A new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? So we talked about in class that if you're having variables on both sides, there are two things you should always look for in order to know that you have to set it up that way. One is you're always going to be comparing two things. And 2 is there's never any really big total that you can put on the other side of the equal sign. So they don't give you a total. That means the expression has to go on the other side. Okay, so we're comparing Cameron's new and old service that he now has. Okay, so he currently pays 95 cents per song. So his old service would be 95x. A new service is 89 cents per song, so 0.89x, with a $12 joining fee, so plus 12. Again, there's no actual total, so we know the equal sign goes in the middle. Okay, so the only thing I can move is 89x. I'm going to subtract it from both sides. This gives me 12 equals 6 cents x. And when I divide by 6 cents, then x equals 200. Now, x stands for right here, which is 89 cents per song, 95 cents per song. So this is songs, right? The other part is that doesn't answer our question. Should Cameron switch to the new service? So the part that's important here is he should switch only if he plans to download more than 200 songs. Okay. And then you have your last one down here. So pause the video, try it yourself. So we have 15 plus 80 cents per song versus his old, which is back up here, 95 cents per song. And you're doing the same thing. So we're going to subtract 80 cents. 15 equals 15 cents. So this gives you X equals 100 songs. So again, at what number of songs does this new service become less expensive? After 100 songs.